Hello students, I am Dr. Vivek Tiwari. Today we will discuss electromagnetic theory lecture. So let us start our lecture. In this lecture we are discussing about first unit's topics. Here today's lecture we will discuss about cylindrical coordinate system. It is second important coordinate system of electromagnetic theory. In this coordinate system, as I have told you earlier when I am teaching you rectangular coordinate system, that first of all we have to find out what are the variable in any coordinate system. So here if we will discuss about the cylindrical coordinate system, so we have to understand that in this coordinate system which are variable quantities. So to understand this, in cylindrical coordinate system, here is a point. First of all, we draw a line and tell it, we can call it the distance of a point from a center. So we represent it by r. So first variable here is r. We are moving from here to there. Second variable, what may be, if we move this point from here to here. So there is an angular change in this line and it is represented by phi. And due to this, what will be the displacement? Displacement will be r phi, r phi. And if we take it d phi, that means a small change. We can also say that this is r d phi. So this second displacement is this. First displacement is this, so it is r. Second displacement is r d phi. Third one, when we move this circle upward, then this is third movement and it is represented by z. So in cylindrical coordinate system, you can clearly see that there is three variable and these are r, second one is phi, and third one is z. These are three variable. As I told you that to understand any coordinate system very clearly, to you have to understand what is the linear displacement, yeah, circular displacement. We will understand it also very well. So first we understand what is the variable in cylindrical coordinate system. So here variable is r, phi and z. Another important thing, what will be the range of these variable? So what will be the range of these variable? So if we increase r in any direction, it may vary from 0 to infinity. It is very important because in previous rectangular system it was minus infinity to plus infinity, but here since line start always from 0 to from 0, so its range will be 0 to infinity. So range of r will be 0 to infinity. Second thing, if we see the second variable, so this will be second variable and it vary in the form of angle. If we denote it by phi, then what will be the its limit? So it can vary from 0 to 2 pi. That means 0 degree to 360 degree. This angle's limit will be 0 degree to 2 pi. So I hope these two limits will be clear. Our third limit is z. So z can vary in this direction until infinity. It can also vary in this direction till minus infinity. So limit of z will be minus infinity to plus infinity. So two important thing each and every should clear about cylindrical system, that is what will be the variable, it will be r, phi and z, and what will be the limit. So limit of r will be 0 to infinity, and you have to also know why it is 0 to infinity. In the same way, limit of phi will be 0 to 2 pi, and limit of z will be minus infinity to plus infinity. And next thing is, if what kind of surface will be there. If we make r constant, then r constant and move phi and z, then we have this type of circular surface. And same way, if we fix phi and increase r and z, then we have this kind of rectangular surface. And in same way, if we will keep z constant and move r, so it may be a circular plate. Here it is showing rectangular plate because it is infinite circular plate, so it may be a circular plate. You can assume these all surfaces when, if you assume any cake, if you assume any cake, then outer surface of cake may be this. If you take any slice of this cake, it may be represented by this. If it cut by in this way, then that means this circular shape, it may be a z direction shape. So you can visualize also by using some example of daily life. Here is three thing is important, I think it will be clear. First one is r, phi, z. Second one is its limit, and third one is what kind of surfaces will be in this cylindrical system. Mathematically, when we will solve any question related to cylindrical system, we have to calculate three things. As I told you earlier, that in any coordinate system, very important, differential length, differential surface, and differential volume. Three thing is very important. So first of all, in any coordinate system, we will try to find out dl. If we will get it dl, then it is very easy to find out dv and ds. Here we will see how. So first of all, if we observe our cylindrical system, so first r is varying. So we will take a small differential length, that is dr, and its direction will be ar. So first a small differential length in r direction will be dr ar. If we go with this path, so what will be the differential change in this direction? We can represent, suppose it is d phi, then this will be the path where we are moving. If we consider a small, if we are considering a small differential change, then it represented by r d phi. It is very important. Here it will be r d phi and its direction will be a phi. So second change in phi direction is r d phi az. In same way, if we will go in this direction, we took a small difference, it is a small length, it is dz az. Now we have differential change in every direction for a cylindrical coordinate system. If we will add, so here we can see dl is equal to dr ar, it comes from here, and r d phi a phi, it comes from here, then dz az, it comes from here. If once you get this dl, then it is very easy to find out dv. Simply multiply dr r d phi dz, you will get r dr d phi dz. So once you calculate dl, it is very easy to calculate dv. In same way, if you want to calculate the magnitude of dl, simply you can write it under root dr square plus rd5 plus dz dr. So if you know dl, it is very easy to calculate dv. Now we have to calculate ds. So to calculate ds, we also need dl. We will see how we will calculate dl. So to calculate ds, so if you have dl, so what is our dl? As we discussed in previous slide, so our dl was, dl is equal to dr ar plus r d phi a phi plus dz az. This was our dl. Now, as I have told you earlier, if you want to find out surface in any direction, suppose we want to find out surface in any cylindrical system in AR direction, mathematically it is very easy. You take this quantity and this quantity and simply multiply. So here we can say in R direction surface will be R d phi dz AR. Same way, if you want to find out surface in a phi direction, then you simply multiply this. This will be a surface in the a phi direction. So you will get dr dz a phi. If you want to calculate surface in z direction, then you have to simply multiply this. It will be give you surface in z direction. So you will get r d phi d r dr d phi az. So if you know dl, then you calculate very easily. If you know dl, you can calculate very easily ds and dv. If you want to visualize d dsr ds phi dsz, so you can see here, this surface is, what is it is, surface in AR direction. This surface in Z direction. This is Z direction. Surface in Z direction. If you visualize surface in A phi direction, you can see this is surface in A phi direction. So here you can visualize. Visualization is just, if you are interested to visualize, then it is okay. Otherwise, mathematically, when you want to understand, yeah, you want to calculate, then if you have to simply calculate dl, and it will, with the help of that, you will very correct ds and dv. You will calculate very correct ds and dv. One another thing, as we have discussed two coordinate system right now. One is Cartesian coordinate system and another is cylindrical coordinate system. So here we will also study what is the relation between Cartesian coordinate system and cylindrical coordinate system. Suppose we have taken a point P and a variable of both of the coordinate system x, y, z is represent uh, variable of Cartesian coordinate system, r, phi, z represent variable of cylindrical coordinate system. So as we know, this is the, if we drop this point here we know phi represent the angle between x-axis and that point, and z will be same for both. So here we can see z is equal to z. In Cartesian system, in cylindrical system, z is equal to z. If we want to relate r, then we can see here r will be equal to under root x square plus y square. And if we find, we want to find out phi, then from here we can see that phi is equal to tan inverse y by x. In same way, this is what if we have given x, y, z. We can calculate r phi z. In the same way, if we have given r phi z, we can easily calculate x, y, z. So if we have r phi z, we can calculate x is equal to r cos phi, y is equal to r sin phi, and z is equal to z. So this is the formula. With the help of that, we can convert Cartesian to cylindrical and cylindrical to Cartesian. Thank you very much for listening this.